Hello, John. I have finished the design of the panel. Today I made second option, but firstly I will start from the supply. Yes, the supply is on the left side. So maybe I will show the left side. In your schema I saw a lot of cables. I'm quite confused how much cables are coming to the each ACB breaker. But here you can see that, for example, to this bus bar it can be 8 cables. I managed to fit everything in 800 millimeter deep, not 1000. But the panel is 2.2 meter and it's quite tight. Here you can see that there is a lot of space. Yes, so from the top to the cables there is a lot of space. It is nicely done that to the main bus bars 3200 the breakers are having the same bus bar. So from the breaker it goes to the main bus duct, and below same situation, the breaker from the bottom supplies the same bus bar. Yeah. This bus bar is 80 by 10, so one bus bar 80 by 10 can manage 1600 and second 1600. Yes. Here the small bus bars are 40 by 10, but they are 4. 1, 2, 3, 4. So it's equivalent of 80 by 10, but one from top, second from bottom. Yeah, and goes to 180 by 10 outgoing. The earth bus bar, yeah, the grounding I made in the middle. I don't know where the cable comes from, top, from bottom, so in the middle. Later in the cable compartment you can add vertical bus bar, like here will be some cable compartment, we can add vertical bus bar here. Next is the field with the 3200 ampere breaker, and as you can see the main duct comes okay, so 3200 is here. The main bus bars are coming here horizontal, later some small part vertical, and all the bus bars are going here to the top. From the top the main 3200 ampere is having 120 by 10, 2 bus bars for each phase, so it's 240 millimeter, 2400 square millimeters for 3200 breakers, so it's very nice. Outgoing, I draw here some main CT 4000 ampere in case you will need some analyzer. Next below is outgoing to another main duct. So this is main bus duct 3200. Below there is outgoing for 2500, and this outgoing is having the RCB earth leakage current transformer. I draw here from the Schneider Electric. It is some kind of original dedicated to Master Pact. It works with VG-OHM relay. As you can see, I don't know, maybe in circuitor is a little bit smaller, but here it takes absolutely perfectly the size of the frame, and even we need here some additional isolators. As you can see, there is some isolator that hold those bus bars. It is needed. So with this current transformer, let's say, we will do some special isolators that will be only inside of the current transformer without supports. It will not influence any way the CT. Yes, it will work normally. It is needed, this isolator. If we will not fit, the breaker will have to go like 5 centimeters lower. Yeah, it is already quite low, and here you have this 3200, 2500, so 1, 2, 3, 4, 5, 6, 12 cables. And if we measure the length, the distance from here to surface, again, from here to surface, we have 470 millimeters. So I hope it's enough for the cables. So because of this big breaker and those bus bars, it is a little bit lower than those smaller breakers. Later at the outgoing of the main 3200 bus duct, we are having one breaker 2500 with outgoing cables. 2500? No, sorry. The outgoing here is 1500 with the also earth leakage current transformer. So here you can see that the current transformer fit very nicely and we have no problem here. Normally, yesterday, further outgoings, the option was like this. I put it separately here. From the main duct, here, it goes, let's say, I show it from the front. From the main 3200 ampere duct, it supplies this 500 ampere breaker, which is on schema. So it supplies, and now the old option was that the bus bars were going to the back, behind the breaker. Here today I made the bus bars to the right. This solution is 150 millimeter more. Here is 2950 millimeters. I find this more nice because here on the right you have bus bars instead of behind. And thanks to it, all the breakers which are here can be horizontal. Yeah. So the 500 ampere, I think, incoming from the generator or co-generator electrogeno, the cable can go here from the top. You can tie it to the cable ladders. It can go on the right side, tie it to the cable ladders, and then go to the big terminals. Everything is nice here with the cables. Right, so this is the incoming going to the common bus bars. Here is also incoming 500 ampere to the bus bars, and outgoing you have one breaker 400 amperes. Here there is some problem with the CT for the earth leakage, this RCBO, let's say, because there is no possibility you will fit here all those bus bars you will take with some one toroid current transformer. It's not enough space. So the toroid for this smaller breaker will have to be somewhere in the cable compartment, like here somewhere installed on the cable ladders with cables. Yes, so here should be the toroid. Here I only draw that if you would like to have some measurement with some analyzer, you can add current transformers. Below there is this small breaker which is 250. The same situation, toroid is quite big, you will not put it here. Here you can put current transformers. I didn't draw the outgoing bus bars from this breaker, it has no sense, but somewhere to the back side maybe I also will add cable ladders here, like if you, let me see, let's say somewhere here we will add cable ladder, so you can add current transformer. Come on. Yeah, here you can install current transformer for the earth leakage and go out with those cables up or down, whatever. Yeah. This solution is here nice because you have a lot of space for new more breakers here, or or regular circuit breakers. On the top there is also some small space for breaker like 250 amperes like here, so nice, and outgoing by cables here. When we move it, I will move it 6000, 2000, 6000, validate. Now this I will attach to the panel. So now this panel is a little bit shorter. As you see, this breaker will have to be connected from the bus bar behind somewhere by cables. So 250 amperes by cables. And outgoing here by cables down. And also you need to imagine here some toroids by the cables, maybe behind the panel, somewhere rear behind. So it's not so easy and nice to connect toroid here. Also there is no space, no additional space. Instead of this breaker like this is the generator. Here is the generator. So you can see I designed some bus bars that you can put the cables by the top, so it takes more space. The advantage of this, there is not a lot of space for new breakers, really tight. When you see you have some space, like here you can add small breakers and here, but it's hard to imagine all those cables that will go to the breakers and from the breakers. Yeah, it's very hard here. Advantage is that this surface could be used for another breaker like this one. So you can add same as in this field. This is like very similar field. Yeah, on the bottom is the same breaker, and on the top you can put the same, and those bus bars can be longer and supply additional big breaker for some kind of outgoing. So maybe this option is good for big breaker as an option. This option is good for smaller breakers, like here 250 or 400, here a lot of 250 or some cricut breakers. Yes, so that's it for this panel. I hope you enjoy it, and let me know what would be the option to make quotation. Yes, thank you.